Hello 10th graders! This is TV High, welcoming you to Teleradyo Eskwela, Tara na! We are glad to be with you in this new normal journey of schooling through radio broadcast. I am your teleradyo host, Teacher Rosala C. Apos from Tagum City National High School. Are you all excited to learn? That is great! Come and join us, stay tuned, and be a one-of-a-kind math talino student. We would like to thank our radio partner, Hope Radio 107.1 DXHS, where we are airing our lessons for junior high school. Thank you for your generosity. Our topic for today will be arithmetic sequences. This topic will be brought to us by our teleradyo teacher, Teacher Kobe Arno Toledo from Tagum City National High School.
Hello, dear students! Now that you are settled in your homes, bring out your pens and notebooks and secure all your learning materials, especially your Mathematics 10 Quarter 1 Module 2. Let us hear our objectives for today. At the end of this lesson, we should be able to define arithmetic sequences, determine whether the given sequence is arithmetic or not, and find the common difference, missing terms, and the number of terms of an arithmetic sequence. Arithmetic sequences will be the first type of sequence that we will be tackling during this quarter. Arithmetic sequences are very useful concepts when dealing with quantities having the same difference between them. For example, if you are selling packs of rice with the same increment such as 1 kilogram, 2 kilograms, 3 kilograms, 4 kilograms, and so on, you can calculate the number of varieties of weights that you can sell using only that information. There are a lot more problems that we can solve using arithmetic sequences, so stay tuned. We have learned all about the general concept of a sequence in the previous lesson. We learned that sequences are not simply a list of numbers put together, but rather sequences are made using patterns. We will start our lesson today with an activity. I will present a situation and then I will give you questions about the situation. Ready? Let's start. You, your parents, and your elder brother go for a walk at Energy Park in Tagum. After a while, you decided to hold a contest of who in your family runs the fastest from the entrance gate of E-Park to the division office of DepEd up ahead. After all of you have ran, you found out that your elder brother ran the fastest at 4 minutes, then you at 6 minutes, followed by your mother at 8 minutes, and then by your father at 10 minutes. So the sequence of your running times is 4, 6, 8, 10. Can you identify the pattern of the running times? I will give you 5 seconds. Are you done? Let us check if your answer is correct. Again, the sequence of the running times is 4, 6, 8, 10. All we have to do is to subtract every previous term from its succeeding term to find out the pattern. Let us start. 6 minus 4 is equal to 2. 8 minus 6 is equal to 2. And 10 minus 8 is equal to 2. Can you see the pattern now? We can see that the succeeding term is 2 greater than the previous term. Given this information, can you give the next term of that sequence? I will give you another 5 seconds. Well done! Since the pattern is to add 2 to the previous term, we add 2 to 10, which results to 12. Therefore, the next term of this sequence is 12. This is amazing! You are now ready to proceed to the next portion of our lesson. In this activity, we tackle the situation of a family and their running times. We found that the sequence of their running times has a pattern of adding 2 to each previous term to find the next term. When a sequence is determined by either adding or subtracting a positive or negative value to a term to get the succeeding term, then this is what we call an arithmetic sequence. Now, let us define arithmetic sequences. An arithmetic sequence is a sequence where every term after the first term is obtained by adding a constant called the common difference. The common difference can either be positive or negative. In the activity we did earlier, the common difference was 2 because it is what we add to the previous term in order to obtain the next term. In dealing with arithmetic sequences, we must be familiar with some terms. A sub 1 is the first term of the sequence. A sub n is the nth term of the sequence. N is the number of terms in the sequence, and D is the common difference. At this point, let us test your cunning in determining whether a given sequence is arithmetic or not. Ready? Let us start. Let us have the sequence -1, 2, 5, 8. Is the sequence an arithmetic sequence or not? I will give you 5 seconds. Let us check if you answered it correctly. What we need to look into is the difference between the terms. Remember, common difference between its terms, which means that the difference between its terms are the same. Let us check by subtracting the previous term from its succeeding term. 1 minus 1 is equal to 0. 2 minus 1 is equal to 1. 3 minus 2 is equal to 1. 5 minus 3 is equal to 2. And 8 minus 5 is equal to 3. Do the terms have a common difference between them? That is correct. They have no common difference. The differences between the terms are different. Therefore, the given sequence is not an arithmetic sequence. Now, if the given sequence is not arithmetic, then can you tell what it is? Of course, that sequence is a Fibonacci sequence. The terms of this sequence are determined by adding 2 previous terms in order to obtain the succeeding term. Observe that 5 is the sum of the 2 previous terms, 2 and 3. This sequence is named after the Italian mathematician Fibonacci. The Fibonacci sequence became a famous point of discussion in studying life forms because its sequence of numbers corresponds to the most common patterns found in nature. Now that you know how to identify whether a sequence is arithmetic or not, let us now proceed to finding missing terms of an arithmetic sequence, the common difference, or the number of terms. It is simple to find the nth term of a sequence given the first term, or a sub 1, and the common difference d. We simply use the formula a sub n is equal to a sub 1 plus the quantity of n minus 1 multiplied by d. I repeat, we simply use the formula a sub n is equal to a sub 1 plus the quantity of n minus 1 multiplied by d. For our first example, we will find the 13th term of an arithmetic sequence with first term, or a sub 1, equal to negative 7 and common difference equal to 2. Since we are asked to find the 13th term, our n will also be equal to 13. And the first term is equal to a sub 1, which is equal to negative 7. And the common difference is 2. We now substitute these values into the formula. Again, the formula for finding the nth term of an arithmetic sequence is given by a sub n is equal to a sub 1 plus the quantity of n minus 1 multiplied by d. Substituting the values, we have a sub 13 is equal to negative 7 plus the quantity of 13 minus 1 multiplied by 2. We simplify what is inside the parentheses first. We then have a sub 13 is equal to negative 7 plus 12 times 2. Do the multiplication operation next. We then have a sub 13 is equal to negative 7 plus 24. Adding the two values negative 7 and 24, a sub 13 is equal to 17. Therefore, the 13th term of the arithmetic sequence with first term negative 7 and common difference of 2 is 17. Now it is your turn to answer. Given the first term, a sub 1, which is equal to negative 7, and the common difference of 2, find the 14th term of the sequence. I will give you 20 seconds to answer this question. Did you get the correct answer? Let us check. Since we are tasked to find the 14th term, our n will also be equal to 14. We are already given the common difference, which is equal to 2, and the first term, or a sub 1, which is equal to negative 7. We now substitute these values into the formula. Again, the formula for finding the nth term of an arithmetic sequence is a sub n equals a sub 1 plus the quantity of n minus 1 multiplied by d. Substituting the values, we have a sub 14 is equal to negative 7 plus the quantity of 14 minus 1 multiplied by 2. We simplify what is inside the parentheses first. We then have a sub 14 is equal to negative 7 plus 13 times 2. Do the multiplication operation next. We then have a sub 14 is equal to negative 7 plus 26. Adding the two values negative 7 and 26, a sub 14 is equal to 19. Therefore, the 14th term of the arithmetic sequence with first term negative 7 and common difference of 2 is 19. If your answer is correct, congratulations! You already understand the basic formula for getting the nth term of an arithmetic sequence. Now, what if what is missing is the first term of a sequence? Let us tackle this next example. Given that the 10th term or a sub 10 of a sequence is negative 28 and the common difference is negative 5, find the first term or a sub 1. I repeat, given that the 10th term of a sequence or a sub 10 is negative 28 and the common difference is negative 5, find the first term or a sub 1. Since the nth term is a sub 10 or the 10th term, our n will likewise be equal to 10. We simply substitute our values into the formula. We then have negative 28 is equal to a sub 1 plus the quantity of 10 minus 1 multiplied by negative 5. We simplify the contents of the parentheses first, which gives us negative 28 is equal to a sub 1 plus 9 times negative 5. We then do the multiplication operation, which gives us negative 28 is equal to a sub 1 minus 45. By the symmetric property of equality, we have a sub 1 minus 45 is equal to negative 28. By the addition property of equality, we have a minus 45 plus 45 equals negative 28 plus 45. This can be simplified to a sub 1 is equal to 17. Therefore, the first term of the arithmetic sequence with 10th term equal to negative 28 and d, or the common difference, equal to negative 5 is 17. I repeat, the first term is 17. Now let us talk about how to find the common difference of an arithmetic sequence. We will practically be using the same formula for this, so don't worry. If we are given the value of a sub 8 or the 8th term, which is equal to 10, and a sub 18 or the 18th term, which is equal to 40, find the common difference of the arithmetic sequence. For this problem, we were not given the first term or a sub 1. To remedy this, we make small changes to our formula. Instead of using a sub n is equal to a sub 1 plus the quantity of n minus 1 times d, we change 1 into k, which makes the formula a sub n is equal to a sub k plus the quantity of n minus k times d, where k is the order of the number nearest the first term and n is the order of the number farthest the first term. We will now begin. First, we substitute the known values into the formula. We already know that k is equal to 8, n is equal to 18, and a sub 8 or the 8th term is equal to 10, and the 18th term or a sub 18 is equal to 40. Substituting these values into the formula, we have 40 is equal to 10 plus the quantity of 18 minus 8 times d, which is the unknown. We first simplify what is inside the parentheses, giving us 40 is equal to 10 plus 10d. By the symmetric property of equality, we have 10 plus 10d is equal to 40. Next, by the addition property of equality, we subtract 10 from both sides of the equation, giving us 10d is equal to 30. Dividing both sides by 10, we have d is equal to 3. Therefore, the common difference of the given sequence is 3. Now let us discuss an example wherein the number of terms, or n, is missing. Now let us have example number 5. Given that the first term, or a sub 1, is 9, the common difference, or d, is negative 1, and the nth term, or a sub n, is negative 9, let us find the value of n, or the number of terms, of the arithmetic sequence. We substitute the known values into the formula, which gives us negative 9 equals 9 plus quantity of n minus 1 times negative 1. By the distributive property, we distribute negative 1 to the terms of the binomial n minus 1, which then gives us negative 9 equals 9 minus n plus 1. We combine like terms in the equation, which then gives us negative 9 is equal to negative n plus 10. By the symmetric property of equality, we have negative n plus 10 equals negative 9. By the addition property of equality, we subtract 10 from both sides of the equation, which gives us negative n is equal to negative 9 minus 10. Simplifying, we have negative n is equal to negative 19. Finally, we multiply both sides by negative 1 to eliminate the negative sign. We then have n is equal to 19. Therefore, the number of terms of the arithmetic sequence is 19. We are now done discussing the basic concepts and some examples about arithmetic sequences. Now let us have a recap. An arithmetic sequence is a sequence where every term after the first term is obtained by adding a constant called the common difference. The common difference can either be positive or negative. Finally, the formula for getting the nth term of an arithmetic sequence is given by a sub n is equal to a sub 1 plus the quantity of n minus 1 times d, where a sub 1 is the first term, a sub n is the nth term, n is the number of terms in the sequence, and d is the common difference. At this point, ready your notebook, your pen, and your brilliant and focused mind, because we will now have our assessment. I will ask only 3 questions for this assessment, but you have to be very quick in answering them. I hope you are ready, for we will now begin. Question number 1. Which of the following is an arithmetic sequence? A. 6, 3, 3 halves, 3 fourths, 3 eighths. B. 3, 6, 12, 24, 48. C. Negative 1, 4, 9, 14. Or D. 2, 3, 5, 7. Again, which of the following is an arithmetic sequence? A. 6, 3, 3 halves, 3 fourths, 3 eighths. B. 3, 6, 12, 24, 48. C. Negative 1, 4, 9, 14. Or D. 2, 3, 5, 7. Your time starts now. Time's up! The correct answer is letter C. Great work! Let us now proceed with the next question. Now let's proceed to question number 2. Given the arithmetic sequence 3, 5, 7, 9, and so on, what is the common difference? Letter A, 2. Letter B, -2. Letter C, 1/2. Or letter D, -1/2. Again, given the arithmetic sequence 3, 5, 7, 9, and so on, what is the common difference? Letter A, 2. Letter B, -2. C is 1/2 and D is -1/2. Your time starts now. Time is up. The correct answer is A, or 2. A very nice job. We will now proceed to our third and final question. Question number 3. What is not true about the arithmetic sequence -2, 0, 2, 4? I repeat, what is not true about the arithmetic sequence -2, 0, 2, 4? Letter A. The common difference is 2. Letter B. The sixth term